Hello and welcome to the next session. So last time we have seen why project fails and some of the methods which we follow, so in order to reduce the project failure. So how do I manage my project? So we use the word project management methodology. So PM or project management methodology provide a set of rules and processes that can distinguish a chaotic means a project which is going to be having a lot of failure, or sometimes it will be having erratically, okay, from a coherence one. So they provide a framework where everyone can act in a greater goal, and laws that do the same for it's like laws do the same for our society. So when we are living in a society, we have to follow certain norms, certain laws. Same is true for data science project. If follow certain norms and rules, then my project management become easy, my failure rate will be reduced. However, laws are not perfect and they often fail. So even in the question of a law, when they fail, so naturally the data science project are often to be failed too. So there is no silver bullet in the world of a software management either. So underlying principle is there is no single bullet, okay, and some management practices are better suited to one type of project and that will let you down to in another. In following, we are going to talk about the project management of the life cycle. Okay, so if we know the project management, we traditionally follow the waterfall model in our software engineering. Now the same waterfall model has been translated into a data science project, and let us see the comparison of the waterfall model for a house building and a software building. Number one point is prepare the building site. So I prepare the map. In software side, prepare the development environment. So what is the environment I require? I require a Keras, I require TensorFlow, I require Python, which is the version. All those requirements are needed for a development environment. Point number two is lay a foundation. So analyze the document and the requirements. So in the point number two, whatever I have done in the building side, I am going to do a analysis and try to see that whatever the whatever development tools I require, they are well documented. Point number three, create a framework. Coming to the software side, analyze and document the architecture and software specification. So there is, you can see a close resemblance between a waterfall model of a house building and a software building in the data science project. Okay, so I have created a framework. The framework is analyzing and documenting the entire architecture of my project. Then build a roof. So I am building the top. So build a system. Next point is connect the electricity and water so that everything get energized. Here what I have to do, in software I will say test that everything is working according to the requirement, and the last is finish the exterior and interior. So I finished the project. So you can see that the tabular form or the column form gives you a very good idea about what we call as a waterfall model in a traditional house development and in the traditional software development. So there is a lot of coherence between the two. So why this model is not suitable? All steps are laid down sequentially and are rarely repeated only once. If you make a single mistake, the project plan will fail apart. This is the whole problem in the system, or when we adopt this kind of approach. A single undocumented requirement such as the step number 2 can result in a disaster at step number 6. So client do not have a complete view of the end result, that can make mistakes too. So requirement can often change and often customers see the actual implementation on the request. So this is the traditional waterfall model failure rate, and it gives you a good insight about the sequence to be followed. However, this suffers from the non-suitability. So what is the next answer? Next answer is addressing the issue. Software project manager know a single waterfall won't solve the problem. So they compare very small waterfall model in a sequential iteration, and this stage of evolution is called as a iterative. So I follow a smaller waterfall model within the same big model and I go on iterating the process. So when I go for a iterating of the process, the end result will be a very good show, and at the end the development show will be a very good intermediate result to show the end user of the purpose of the collecting the feedback, and this feedback I can use to jump start the next iteration. So same waterfall model redesigned in a smaller manner can be beautifully working for a data science project. The second methodology we use in our traditional software development is agile, very popular, and most of the people follow this because this gives you a faster response, faster reply. So, we already know about the agile technology from the software engineering. I will just read out the point and take it. So, number 1, individual and interaction take precedence over the processes and tools. Number 2, working software takes precedence over a comprehensive documentation. So, this is another very good point about the agile methodology. Documentation can be done later. First thing is the software has to be developed and it has to be implemented on the site. Number 3, customer collaboration take precedence over a contract negotiation. So, this is instead of going with a contract negotiation, let the customer collaborate with you, and negotiation can be done later, or a contract or a service level agreement can be signed later. Responding to change take precedence over following a plan. So, if you look at the agile methodology, the project will be more and more successful, customers are happy, and you are also getting lot of revenue generated from the software development. Okay. Another is a beautiful project management tool called as a Kanban. So, Kanban is best metaphor for explaining is a conveyor belt. So, I have a conveyor belt, and on a conveyor belt I have so many objects straight. So, what is the best strategy I will follow? I will show you. Okay. So, imagine that your task go through a fixed number of stages before they are being finished. The concrete definition of this stage is up to you. So, in software project management, you want to use the following process. Number 1, backlog, that is buffer where incoming tasks are being collected before they are being processed. Number 2, requirement specification. 3, development. 4, code view. 5, testing and deployment. These are all our traditional steps which we have followed. Now, in Kanban, Kanban visualizes each task on a board as shown in the figure. So, I am showing you a figure. You can see the figure. If I see the figure, I have a conveyor belt, and on the conveyor belt I have a backlog. Backlog means still they are to be finished. So, if you see here 1, 2, 3, 4, 5, 6, 7, 7 are 7 code piece of code or 7 stages has to be crossed. Okay. So, when I go with the Kanban principle, I will say okay, how many are in progress. So, I say 3. How many have been reviewed? 2. So, how many are tested? So, you can see here 3 plus 3. Okay. So, 1 is a defective one. So, it becomes easy for me to identify the defective or a track. Okay. So, this is the way a Kanban process works. Okay, and done processes and block processes. So, you can see that on a conveyor belt, if you have a lot of material going, then naturally some processes will be blocked, some processes will go through, some processes will get reviewed. This is similar to a X-ray machine. When we go to the airport, it scans all the information and know which area or what information to be blocked, which information need to go, and things like that. So, this is another Kanban process project management tool. So, each stage should have a limit regarding the tasks that can be done in a parallel. So, Kanban purposely limit the number of simultaneous tasks to increase the throughput, and if the team become blocked because there are many tasks sitting on the deployment or development process, then all the team members are capable of making the shipment at the end of the production only. So, should we stop talking about that such tasks and switch getting reading of the bottleneck. So, the problem has been resolved and the team may decide to do for another task too. Okay. So, the priority keeps on changing in Kanban. So, Kanban favors cross functional team. So, a one person working on one project can develop the code and can do a testing of the code on another project too. So, it is a cross functional one, and Kanban focuses on completing a single task from start to finish as fast as possible. Okay. The main metric that can be used to measure the effectiveness of the Kanban project is followed. Very simple: lead time, the time it takes for a task to move from a backlog to being completed on an average. So, you can see that the project life cycle become very fast, and cycle time, the time it takes for a task to move from a starting stage to a completion stage on an average. So, cycle time would be between the requirement specification and the deployment. So, you can see that we have a number of parameters to measure in the Kanban, and the first last parameter is throughput. Average number of tasks that you can be done during a time interval, that is a per day, per week or a per month. So, what is my throughput? How many tasks I am able to complete? So in general, we don't create a fixed project plan and fixed deadline when using a Kanban. Okay, so Kanban powers are also limitations, some of which are: Kanban works best when the amount of work in each stage of your task is the same. If the tasks are taking significantly longer than the other, the matrix will stop using them. So this is another limitation of the Kanban. And if you do not want to work as a cross-functional team, your throughput will suffer from the bottleneck, which makes using the Kanban a worthless. Last, Kanban does not give you the tools you need to manage the deadline, because there is no deadline available. As it goes on, it will work. Okay, project scope and budget. So this single thing takes care of the optimizing only throughput. So this is another technique. Kanban is a great software management approach for project with repetitive tasks. So it can also be partially applied to the parts of the project where it makes a sense of use it. So for example, in software support project management, when we should take care of the deployment and fixing the issues. In data science project, we dedicate a team and perform experiment on the machine learning model. Tuning Kanban will help increase their throughput. And project where you are using to create a lot of similar things such as 100 of web form, data mapping or identical machine learning model, then Kanban is a beautiful project management technique. Okay, another another very interesting method is called as Scrum. Scrum is another popular project management methodology from the Agile family is your Scrum, and the main idea behind the Scrum is a sprint. Sprint tells me a work to be done very fast. So maybe when I am trying to reach my college or reach my class, I put a sprint, I run faster. So the sprint is a set of tasks with a fixed deadline and duration. So typical sprint durations are 1 week, 2 weeks and sometimes maybe 1 month. So Scrum processes are backlog grooming, sprint planning, sprint execution and retrospective. That means I have to go back and try to find out what was the problem. Okay, so this is the another technique, and the main component of Scrum is the sprint. A sprint is actually a iterative or iteration process within a fixed deadline. So you have to complete, so sometime you have to work extra, sometime you have to work faster, and that is what the project management tool is all about. So typical length of the sprint is around 2 weeks. It always starts with a sprint planning meeting where the team members develop the project backlog and then try to find out the work and try to finish the work. So consider a task with 1 story point trivial and a task with 2 story points. So what we do in our Scrum or sprint is we try to generate a kind of a story. Story is nothing but a small narration of the task to be finished. So another system of story point estimate that suggests using a power of 2 or task estimation. So we can do a task estimation how long it is going to take. We try to reduce the task estimation by using principle called as sprint, which will say that you have to work faster. So the job which was supposed to be done in 2 weeks time, can it be done in 1.5 week time? So if it is able to do in 1.5 week time, I have achieved a milestone. Okay, so this is what about the sprint problem. Okay, so this is more details about the sprint. You can go through it, and in practice, okay, this kind of job using the sprint is very good for business to business customer. So B2B environment, and for situations we don't have no option but forced to change the sprint, then scope will have 2 options. Trade the task, then you can move a task from a sprint and add to another one, or start a new sprint, that is you can stop the current sprint task and take another one. So these are all the project methodology which are available, and in our software engineering also we have learned about the software SPM. So, okay, so what is the method to choose our project? So choosing a project management methodology becomes a captivating a complex task. You can spend a lot of time thinking about one approach that will support a process rather than the other approach. So what is the answer? Answer is a disruptive technology. Disruptive technology tells me that a new technique will disrupt the other older technique. So if you create a solution that should disrupt the market, the only thing that matters is the efficiency of your methodology. You won't have many customers at the end of the project, so you should be able to collect feedback and perform a focused one on the iterative basis. So Scrum works in such situation best. You can implement new features regarding the sprint and collect the feedback at the end of the sprint, okay, to start a new iteration. So this is one of the way where you can solve the problem. Another is a tested solution. So if you have tested already a solution, repeat the same thing, because you already know the solution was giving a good result. So that is another technique which we use in the project management. And developing a customer project for a customer. So I can, if I have developed a project for a one kind of customer, if the similar work comes to for another customer, I will go with the project which was developed for one customer and for a new customer. For example, banking software. If I have developed a banking software for bank, let us say State Bank of Travancore and things like that, then I can go for the similar software of a banking for another customer too. So this way it will help me to reduce my time. So with this project management issues, we can see that our software in the data science team become very effective if we follow certain good practices and we follow some of the agile methodology or sprint methodology. Thank you.